All right, welcome to the Explainer. Today, we're going to demystify something that's, absolutely fundamental, but also super powerful in the AWS cloud: network connectivity. We're going to break down all the essential pieces you'll need to build a really secure and scalable network step by step.
So here's the big question, right? How do you actually do that? How do you carve out your own private, protected space in this huge world of the public cloud? Well, the answer starts with one core concept. It's really the foundation that everything else is built on. Okay, let's dive right in. The very first, and honestly, the most important piece of this whole puzzle is the virtual private cloud, or as you'll always hear it, the VPC. Just think of it like your personal, totally customizable blueprint for all of your networking in AWS. So, what is a VPC? Well, it's your very own isolated slice of the AWS network. It's a virtual space where you are in complete control. This is the spot where you're going to launch your servers, your databases, all your applications. And they all live inside a network boundary that you get to define and, most importantly, secure. And when I say complete control, I really mean it. Inside a VPC, you decide everything. I'm talking the IP address ranges, how you're going to split your network into public and private subnets for different kinds of access. You even control the route tables that say where traffic can go, and the super specific firewall rules, your security groups and NACLs that protect it all. It really is your private cloud. So, you've built this perfectly isolated island in the cloud. That's fantastic for security, right? But what happens when you actually need to connect to the outside world? Let's talk about how we open the gates to the internet. The first and most common way to do this is with an Internet Gateway, or IGW. You can think of this as the main front door for your entire network. If you've got a web server or some app that needs to be public, the IGW is the piece that makes that two-way communication with the internet happen. Now, this is super important because it highlights a classic mistake people make. Just creating an IGW, well, that's not enough. For it to actually work, you gotta do three things. First, you attach it to your VPC. Second, you have to explicitly add a route in your route table that points internet traffic to it. And third, the thing you want to be public, like your server, needs a public IP. If you miss even one of these steps, it's just not gonna work. Okay, but this brings up a huge security question. Think about it. You've got these private database servers, and you definitely want them to download security patches, right? Of course. But what you absolutely do not want is for anyone on the internet to be able to connect into them. So, how do you solve that little puzzle? The answer is a NAT gateway. NAT stands for Network Address Translation, and it's basically a secure one-way backdoor. It lets your private stuff reach out to the internet to grab updates, for example, but it completely blocks any new connections trying to get in from the outside. So the key takeaway here is your private resources stay totally private and secure, but they can still phone home when they need to. All right, so things are going well. Your architecture is getting bigger. Now you don't just have one VPC, you have a bunch of them. Maybe one for dev, one for testing, one for production. How in the world do you get them all to talk to each other securely without sending that traffic out over the public internet? Well, the simplest way is something called VPC peering. The best way to picture this is like a private, secure walkway that's built directly between two VPCs. Once you set that up, the resources in both VPCs can just talk to each other using their private IPs, almost like they're on the very same network. For connecting just two networks, it's super simple, and it works great. But, and this is a big but, here's the catch. VPC peering is non-transitive. What does that mean? Well, if you connect VPC A to VPC B, and then you connect B to C, A still can't talk to C. The connection doesn't pass through. You'd have to build another direct connection between A and C. You can see how, once you get more than a couple of VPCs, this turns into a total mess, a web of connections that people call the mesh nightmare. And this is exactly why AWS came up with the Transit Gateway, or TGW. It's the solution to that mesh nightmare. Instead of all those messy point-to-point connections, the TGW acts like a central hub, a cloud router, basically. All your VPCs just connect to this one central hub, and the TGW takes care of all the routing between them. So much cleaner. Let's just put these two side by side for a second. With peering, you've got that point-to-point, non-transitive mess that just doesn't scale. With a transit gateway, you've got a clean hub-and-spoke model, the routing is transitive, so everything can talk to everything else through the hub, and it can scale up to thousands of VPCs. Honestly, for any environment that's even a little bit complex, the TGW is the hands-down winner for easy, scalable management.
Okay, so we've connected our VPCs to the internet, and we've connected them to each other. But what about that final piece of the puzzle for a modern enterprise? I'm talking about connecting your AWS cloud all the way back to your own on-premise data center. You know, building a true hybrid cloud. So you've really got two main tools for this job. First, there's a site-to-site VPN. It's pretty quick and cost-effective. It basically creates a secure, encrypted tunnel for you over the public internet. It's awesome for getting set up fast or for a backup connection. But if you've got serious, high-performance workloads, you're going to want to look at AWS Direct Connect. This is the real deal. A dedicated, private fiber optic line straight from your data center into the AWS network. We're talking massive speeds and super stable, low latency. Okay, I know that was a ton of information. So let's do a quick, rapid-fire recap just to lock all this in. The best way to remember this stuff is to think of each component as a specific tool in your networking toolkit. Your internet gateway, the IGW, that's your public front door. It lets traffic flow both in and out from the internet. Your NAT gateway, that's the secure back door. It lets your private stuff get out for updates, but it doesn't let anyone from the outside get in. VPC peering, that's the simple walkway. It's perfect for connecting just two VPCs together directly and privately. The transit gateway. That's your big, scalable network hub. It's the solution for taming that complexity when you've got a whole bunch of VPCs to connect. And finally, your VPN and Direct Connect, those are your bridges to on-premise. They're what connect your AWS cloud securely back to your own data centers. So there you have it. You've used all these tools to build a networking masterpiece. It's secure, it's scalable, it's all connected. You've laid all the pipes. But that brings us to the next massive question, doesn't it? Now that it's built, how are you going to manage that giant river of data that's about to start flowing through it? We'll have to tackle that in our next explainer.